little over a year ago, I was standing in front of you talking about economic development. And I was talking with our chairman, Rocky Pierce, and our executive committee, which is here. And the leadership of Florence has delivered on some very special things. Literally in the last 14 months, with 8% inflation, Florence County had the biggest year economically in its history. I'll let that sink in a little bit. We attracted businesses, expanded operation. We jump-started some ambitious goals with 2 speculative buildings and 5 industrial parks. We're setting it at record pace, almost Darlington Speedway pace, as the hub of the PD in Florence County. Not even the ongoing impacts of COVID or elections are going to slow us down. Our county leadership, our city leadership, our partnership, our progress, our medical community, as well as staff have been dedicated to making economic development the #1 priority in this county. To date, in the last 14 months, close to $1 billion has been publicly announced in the last 14 months, and over 1,800, close to 1,900 full-time jobs are announced, and we're not done. AESC held the groundbreaking in June, $810 million and 1,170 jobs, which is the largest single investment in the history of our county. Let's take it a little further. The region, a little bit further, Eastern Carolinas. Pretty special. That brings us to why I'm here today, to introduce Mr. Jeff Deaton. His company's investment is going to transcend the opportunities in front of us for future generations. Jeff is the managing director of AESC, and in his role, he is responsible for U.S. business operation and facilities in Smyrna, Tennessee, Bowling Green, Kentucky, and of course right here in Florence, South Carolina. With an exceptional blend of leadership and strategic insight and operational experience, Jeff has consistently delivered results and propelled organization to new heights. Jeff previously worked with Nissan North America, where he had a number of roles, and he was with Nissan's powertrain operations in the Deckard, Tennessee location, and in the Smyrna vehicle assembly plant, which included engineering, quality, as well as operations. Personally, Jeff earned his Bachelor of Science degree in mechanical engineering, very fitting, from the University of Tennessee at Chattanooga, and an MBA from Vanderbilt University. Outside of his professional endeavors, Jeff enjoys spending time boating with his family, as well as competing in ultra marathons. All right, for those that don't know what an ultra marathon is, that's someone who says that a marathon isn't hard enough. And when I was just talking to him, I said, "What is the furthest race you've done?" He said, 500 kilometers. Correct me if I'm wrong with that, Jeff. And I said, "Well, wait a minute, how far is that?" He goes, 314 miles. We're talking multiple states here. 10 days to finish, he finished it in 6. Pretty amazing. On a personal note, I have learned that Jeff truly understands that leadership is about hiring and surrounding yourself with great people. And I have learned that with the AESC team. They are phenomenal. They are exceedingly bright, and we are delighted to have them as part of the fabric of our community. He knows that Florence County will answer the call of business, and that our location where innovation and drive come together, where access to talent and connections are unequal. This opportunity in front of us is real, and it is very rare. Please join me with a very warm Florence County welcome to Mr. Jeff Deaton.
I think you gave away all my secrets. All right. Thank you, Greg. Some of that stuff's true. The ultra marathon thing, I think it's just like the industry I'm working on. We enjoy suffering. We've seen a lot of changes in this business, and it's amazing the way it is today. So it's an honor to be here today. I want to thank the Chamber for inviting me to come here and share a bit about AESC. And I want to tell you about our company in general and then what we're doing here in Florence. I'm going to talk a lot about batteries as well. So I suggest if anybody has caffeine at their table, please drink a lot of it because it's going to get boring. And I'll try to make it as entertaining as I can. I can't promise anything. So let's start with AESC. So about 20 years ago, Nissan made the decision to develop and produce the world's first mass-produced electric vehicle, which later became known as the Nissan Leaf. Well, back then, there weren't any battery suppliers that were willing to develop the product and make the batteries that was needed for that vehicle. So Nissan took it upon themselves and created their own battery company, and that was known as AESC. It was a joint venture with NEC, and it was formed in 2007. So then in 2012, the first battery plant in the United States for AESC started mass production, so a little more than a decade ago. And that plant's produced over 80 million battery cells today. So Nissan didn't have the intention to stay in the development and production business for making batteries long term. They always intended to sell the business. So in 2019, they successfully did that, and the business became an independent company with headquarters in Japan. So in just the 16 years since the formation of that joint venture, AESC is now recognized as a world leader in lithium-ion battery technology. So AESC was basically a captive supplier within the Nissan family. And it's very difficult as an automotive OEM to sell your components to one of your competitors for a variety of reasons, but mainly antitrust, because those other competitors have to share their product plans and schedules with you. So the AESC business stayed relatively small and only supplied Nissan. But in the short 4 years since we've become an independent business, we've been fortunate enough to earn the business from lots of other global leading automotive companies. Those companies include Mercedes-Benz, Renault, Jaguar Land Rover, Tesla, Hyundai Kia, Honda, Mazda, and most importantly for Florence, BMW. So here's a map of the EV network supply chain for BMW in the state of South Carolina. So if you look to the right, you can see the Florence plant will make battery cells and supply those to Woodruff, South Carolina, where just a couple of months ago, BMW broke ground on their new facility there. So that'll be the customer plant from Florence. That facility will take our battery cells and they'll create battery modules and battery packs that'll then be shipped to Plant Spartanburg, where they'll be fitted to electric vehicles for BMW. You also note that Port Charleston is on the map. So as some of you may know, BMW exports more than 60% of their production in South Carolina outside the United States. So what that means for Florence, the batteries that we produce here, more than half of those will end up for use outside of the United States. So let's talk more about AESC's global footprint. So AESC is truly an international company. We not only have operations in the United States, but also in the UK, Japan, France, Spain, and China. This industry is experiencing unprecedented growth, and AESC is capturing a fair share of that market growth. So the typical measure for capacity of a battery plant is in gigawatt hours. Everybody here knows what a gigawatt hour is? Right? Nobody knows what a gigawatt hour is. What is that? So let me give you an example. If you make an electric vehicle that has a 100 kilowatt hour battery, which is very common in the industry today, then 1 gigawatt hour of production capacity in a battery plant can supply enough batteries for 10,000 of those vehicles. So the plant we're building here in Florence is 30 gigawatt hours. So that means it could power 300,000 electric vehicles annually with those batteries. Hopefully that gives you a little better perspective on what's a gigawatt hour. Globally, AESC today has 60 gigawatts hours of production capacity. And then in the next 3 to 4 years, we plan to grow that to over 400. So next, let's talk about the AESC US location. So we have a facility in Smyrna, Tennessee. As I mentioned earlier, it started production in 2012, and it produces pouch battery cells for the Nissan Leaf. That facility is about a 3 gigawatt hour capacity plant and has around 500 employees today. Our next site's in Bowling Green, Kentucky. So that facility is for Mercedes-Benz, and we'll supply product to their facility that's just outside of Tuscaloosa, Alabama. And in fact, just last week, the Bowling Green team celebrated putting the last piece of steel on the first building in that campus. So that was a huge milestone for us. Also to note, schedule-wise, the facility in Bowling Green is about a little more than a year ahead of the schedule for Florence. So just to give you a perspective on where we are in terms of our expansion in the U.S. So next, let's talk about batteries. I imagine in this room today, there's probably 500 to 1,000 different batteries in this room right now. I've got one on my smartwatch, my iPhone that's in my pocket. The computer I'm driving the presentation with is powered by a battery. So batteries are in, the cars you drove here today probably have batteries, right? So batteries are in all kinds of devices that we use every day in our normal lives. And batteries have been around a really long time. Technology-wise, in the 80s, nickel cadmium and nickel metal hydride was the primary technology that was in the market. But in the early 90s, lithium-ion batteries came onto the market to scale with high quality and performance, and now it's the dominant technology for batteries for a variety of different products. So this is a market forecast globally for batteries. As you can see, from 2021 to 2030, the market's expected to grow by 400%. It's a huge amount of growth. And you can also see there's a variety of different product technologies in this map. The lithium ion has more than 60% of the global share. And it's forecasted to achieve more than $400 billion in size. Okay, so how many of you here know how to make a lithium ion battery? People at this table here, they can't answer. So a lithium-ion battery really has 4 main components. There's 2 types of electrodes. There's an anode and cathode, and they're separated by a separator film, so you don't want those 2 films touching each other. And then last component is a liquid electrolyte. And that liquid electrolyte just creates a path so that those electrodes can share lithium ions back and forth. So the way the battery actually works, so when you're using the battery, those lithium ions, as you can see in the illustration, they move from the cathode to the anode, which creates a current. That current can be used to power your device, whether it's a motor, a computer, whatever the device is. And the beauty of the lithium ion technology is you can recharge the battery thousands of times. So when you recharge the battery, those ions move back from the anode to the cathode. In simple terms, that's how a battery works. So next, let's talk about what we're doing here in Florence. And there are 3 different types of batteries for lithium ion that's used in electric vehicles. So if you look at the far left of the screen at the top, that's an image of a pouch battery cell. Imagine just a legal pad that's wrapped in aluminum foil. That's the form factor that we produce in our Smyrna plant today. The one in the middle is a prismatic battery cell. That's what we're going to produce in our Bowling Green facility and also in our Tennessee facility in the future. And then lastly is a cylindrical cell. And that's what we're going to produce right here in Florence. So here's a sample of the battery cell that we're going to produce here. It's called a 46120. It's 46 millimeters in diameter, and it's about 120 millimeters tall. So you can see it's kind of shaped like a D-cell battery, but maybe one that's on steroids because it has lithium-ion technology. At the bottom right, you can see a sample flow chart of how the battery is made. But in essence, we take those, the two electrode films, the anode and cathode, with the separator film, that's rolled up into a roll, and it's inserted inside this metal can. And then lastly, we put a liquid electrolyte inside, put the cap on, laser weld it, and that's how the battery is made. It's a lot more complicated than that, very sensitive processes, but in essence, that's how the cell comes together. So next, let's talk about the site. So some of you are probably familiar that if you look at the logo in the very middle where it says AESC, that's the site where we're building the plant. It's directly across the street from Wilson High School. So it's bordered by Old Marion Road, Estate Drive, and John C. Calhoun Road. The site itself is about 500 acres in size, and we're only using a small part of that for the first building. So what that means, what's really important about that is we want to expand our production capacity here, and that land is enough for us to do that in the future. We're also working with AESC to build an on-site training center. So there'll be an AESC training center on the campus. So this is a rendering of the new facility. So if you look up to the top left, you can kind of see Wilson High School. But this will give you an idea of what the facility should look like when it's completed. It's going to be north of 1.5 million square feet, and it'll have all the advanced production technologies to build high quality and safe batteries for BMW. So next, let's talk about the production environment, what it's like to work in a battery plant. So batteries are very sensitive to contamination and also humidity or moisture. So inside the battery plant, it's temperature controlled, it's very clean, and again, we control the humidity within the clean room processes. So about half of the building will have clean rooms built inside of them, where we have to filter the air, and then we reduce the moisture in the room to minimize the impact of the battery. And inside the rooms will be processes where the battery is exposed to the environmental conditions. So we have to make sure that they're appropriate to protect the performance of the battery. And safety of our employees and also the local community is our top priority. It goes without saying, but I'll say it. We'll comply with all the local, state, and federal regulations. And we produce batteries in our Smyrna facility for more than 10 years with an outstanding safety and environmental track record, which will continue here in Florence. On site, we'll have several laboratories with a lot of sophisticated equipment. In essence, we'll be able to test and validate all the incoming materials that go into the batteries, as well as the finished batteries to make sure they meet the required specifications for our customer. This is a picture from our announcement at the Performing Arts Center back in December, who, along with Governor McMaster and several of the key local leaders, we announced that we were going to build a battery plant here in Florence. Okay, so coming to Florence. So the process to win the business from BMW was a very long and difficult process. Gaining the business with a key company like BMW, which is a world-renowned luxury brand vehicle, is very difficult. They scrutinize every aspect, especially for a company that's going to make something so important as a battery for an electric vehicle. So that was a very long and arduous process, but in the end, we were able to earn that business, which we're really proud of. But then to decide where to build the production facility was also very difficult. So we hired a site selection consultant. We looked in a number of the southeastern states to look for sites and consider where we should build it. And ultimately, we decided that South Carolina was best for us, mainly due to its automotive manufacturing and supply chain heritage. And then even within South Carolina, we looked at a number of different sites in addition to Florence. But ultimately, we decided Florence was the best fit for us. Supply chain efficiencies here look very good. Skilled workforce development looks very promising as well. But ultimately, what we learned from the local community and all the groups that are involved here is that Florence wanted us to come here. And they were very energetic, passionate, willing to support us and partner with us. And it just felt like the absolute best fit for us, and that's why we chose Florence. That's a key testament to the local leadership that you have here. They're doing an outstanding job. So community involvement is really important to AESC. This is some images of some activities that we're doing with the United Way and also with the Boys and Girls Club. We support those organizations in a variety of different ways, and we look forward to creating those partnerships with the local community here in Florence in the near future. So next, let's talk about the site itself, the current status. As you know, we broke ground back in June and immediately started the site work. So I'm happy to say today that the site work is more than 50% completed. The building design itself is also more than 60% completed, and everything's on schedule today. We have our construction trailers on site, and they've also established the temporary power supply to the site as well. So probably in the next few months, you'll see the building start to get erected, and that'll lead up to the building completion about a year from now when the first production line arrives for installation. And that production line will be used to make samples and test parts so we can validate the equipment, the process, and the finished product and ensure it meets the customer's specifications. And then while that testing is ongoing, we'll continue to install additional production lines, hire more employees, training activities will be ongoing, and all that will lead to our start of mass production in 2026. And lastly, over the last several months, we've laid the foundation to build a talent pipeline for our team. We've partnered with the local resources shown here, and we're also leveraging our valuable training center programs that will be offered at our AESC Training Center. Recruiting's begun, and we've started filling a lot of the key project roles. We probably have anywhere from 12 to 15 employees today, I believe. And that recruiting will continue in the near future. And then we also, with this training center that I mentioned that we're building with AESC, we look forward to the graduation of the first graduates from that in 2025. So that'll be here really before you know it. So it looks like most people are still awake. I think there's a few nodding off. But hopefully this was informative. I appreciate your attention. Thank you.